Hi again, welcome to the second section. This section is entitled JUnit 5 Programming Model. In this section, we are going to learn how to write tests based on the JUnit 5 programming model, called Jupyter. To that aim, this section is composed by 8 different videos, namely 1. Standard tests, 2. Assertions, 3. Tagging and filtering tests, 4. Conditional text execution, 5. Nested and repeated tests, 6. Dynamic texts, 7. Dependency injection, and 8. Test interfaces. Let's move on now to the first video of this section about standard tests. In this video, we are going to analyze the structure of unit tests. Then, we describe the details and annotation involved in the management of the test lifecycle in the JUnit 5 programming model. Finally, we describe how to change the display name for the test in the JUnit Jupyter model. In software engineering, given a system or piece of code, software testing consists on the observation of a sample of executions called test cases. In the end, these test cases provides a verdict over the system under test. Depending on the size of the component being tested, we typically speak about unit integration and system testing. Originally, the JUnit framework was conceived as a unit testing framework. Nevertheless, it can be used for different types of testing, simply changing the size of the unit under test. Now, let's focus on test cases. Conceptually, we can see unit tests as small pieces of code composed by 4 different stages. Again, this conceptual model can be reused even when we carry out integration or system-level testing. Let's analyze these general 4 steps within a test. First, we find the setup stage. In this step, a test initializes what we call the test fixture, that is, the before picture required for the system under test to exhibit the expected behavior. This is an optional stage, but it is very commonly carried out by tests. In the second step, the test interacts with the system under test, getting some outcome from it as a result. This stage, together with the third one, is what makes a piece of code become a test. In the verify stage, the outcome from the system under test is compared to the expected value using one or several assertions, also known as predicates. As a result, a test verdict is created. A test verdict can be seen as a Boolean value which indicates if the test is a success or a failure. Finally, we find another optional stage called teardown. In this step, the test releases the test fixture to put the system under test back into the initial state. Let's focus now on the JUnit 5 programming model. In Jupyter, the different parts of a test are identified using Java annotations. The most basic JUnit annotation is test, which identifies methods that have to be run as tests. Unlike JUnit 4 test annotation, this annotation doesn't declare any attributes. For example, as we will discover in video 2.1, expected exception and timeouts can now be verified with their own dedicated annotations. Take a look to this small Java class. Possibly, it is the simplest test case we can create with Jupyter. It has simply a method with the test annotation. Notice that, unlike in JUnit 4, neither test classes nor test methods need to be public. The following annotations, located in the package org.junit.jupyter.api, allow to control the setup and teardown stages in JUnit 5. On the one hand, before each denotates that the annotated method should be executed before each test method in the current class. This annotation is analogous to JUnit 4's before. On the other hand, after each denotates that the annotated method should be executed after each test method in the current class. This annotation is analogous to JUnit 4's after. Notice that such methods are inherited. The before all annotation denotates the method that should be executed before all test methods in the current class. This annotation is analogous to JUnit force before class. Finally, the after all annotation denotes the method that should be executed after all test methods in the current class. This annotation is analogous to JUnit force after class. Due to the fact that a new instance is created for each test, there is no obvious instance on which to call the before all and after all methods, so they have to be static. In addition, these methods are also inherited. Now, let's back to the generic structure for tests we saw at the beginning of this video. Now, we are able to map the following Jupyter annotations with the different parts of the test case. Therefore, we carry out the setup stage by annotating methods with before all and before each. Then, we code test cases in methods annotated with tests. And finally, we carry out the teardown processes in the methods with after each and after all annotations. Let's see a simple example which uses all these annotations in a single Java class. This example defines two tests, that is, two methods annotated with tests. Then we define additional methods for the rest of the test lifecycle with the annotations before all, before each, and after all. If we run this test class, first the before all will be executed. Then the two test methods will be executed sequentially, that is, first one and then the other. In each execution, the setup method annotated with before each will be executed before the test, and then the after each method. Notice that the second test is going to fail due to the fact that we are invoking the fail method, which is a special type of assertion to declare a test as a failure. The rest of assertion will be explained in the next video. The last thing we see in this video is the annotation display name. This annotation declares a custom display name for the test class or test method. This name will be displayed by test runner and reporting tools, and it contains spaces, special character, and even emojis. Take a look to this small example. Here we are annotating the test class and also the three test methods declared inside the class. As a result, we will see these labels in a test runner, such as in the IntelliJ integrated development environment.